And now how do I open?
So on the top, there should be a thing that says like, sorry, you on here, let me see. I'll share my screen. I'll show you.
Okay, let me go back over there. So does this one have to be posted? This one doesn't have to be posted, does it?
I don't know. I just did it just in case. And I was like,
And I appreciate it too, though, by the by.
oh yeah, no problem. Okay, so click homework quiz.
Oh, go into it that way. Okay.
And then there's this little arrow up here, and you just do view submissions.
Oh, wait, then I should be able to do it this way. Submissions, there we go. I can do it from the screen. And then it gives me attempt 1 or attempt 2. So attempt 1, let's see here. What do we got? This is lesson, this isn't the right one. Lesson 3 homework? No. I want lesson, was this lesson 3 homework quiz? No, that shouldn't have been the right, that wasn't the right one.
Lesson 7.
I don't know why it was lesson 7. Now all of a sudden it's lesson 3. Sorry, give me just a second.
Oh, you're fine.
Okay, so we'll do this again. Go back. Okay, so lesson. Oh, here we go. So future quizzes, unit exam, lesson. Huh, for some reason that's weird. It's not coming up. Let me go into it the other way then, I guess. Group meeting, homework quiz. Okay, here we go. Here we go. Lesson 7, homework quiz. There we go. Submissions. Oh, look, they both were 5 out of 10, so I guess it doesn't matter which one I pick up, does it?
No.
Okay. All right, so let's go down there. Okay, so I got question number, it was the probabilities when it changes. Okay, so like I got question number 2 right, which was 0.218.
Okay.
For the probability that a randomly selected person would score above a 157.
Okay.
And then it's what is the probability for 5 randomly selected people. And so do you just divide that by 5?
No, so what you'll do is so you do 157 minus 150
Okay.
divided by the standard deviation of 9. So let me do that real quick. So 7 divided by 9, and you get 0.77777.
Right.
So then you come and you go into the applet, and I'll show my screen again.
Oh, let me pull that back up again so I can, let's shrink this way. And then there's your screen. So let me shrink that over there and put it over here. So now I can see everything.
Okay. So you do the applet, and you come and you say, okay, this was a positive number, so I know that it's going to be over here on the right. So they want to know everything above this. So I always just hit refresh and start from a clean slate. So I this blue one, and then in here for my z-score, I put in 0.778 because I rounded.
Right.
Hit enter, and then right here where it says area, this is your answer.
So what does that say?
It says 0.2183.
Okay, but that's for one person. So now what about 5 people?
Oh yeah, so then for the 5 people, you do So you do like this. Did you download Desmos?
I actually, no, I forgot all about that yeah.
So then you'll do this. You'll come to Desmos and you'll put in, okay, 157 minus 150. And don't forget your parentheses, otherwise it messes everything up. And you'll do divided by crap.
Isn't it like the square root of something?
Yeah, so it's 9 divided by the square root of 5, which is the sample size.
Oh, that's where I messed up. Okay.
And you put that in. So now we have 1.739. So then we come over here and we put in 1.739, enter, and our area is 0.041.
Okay, that's where I made the mistake, was the 9 divided by the square root of 5. For some reason I was dividing it by the square root of 9, I think. So then the next one you would do the 157 minus 150 divided by 9 divided by the square root of 10, correct?
Yep.
Okay. So then that would give you whatever that answer is. Let's see here. So the 0.007.
Yep.
Okay, let me go down. So then here we on okay, so on question 5, which I got correct, that the mean was 3.7 and the standard deviation was 0.113.
Okay.
But on question 6, it says, what's the probability that the GPA for 64 random selected students would be less than 3.5? And I was nowhere, because is that the 3.5? Is that a different sample size, or how does that work?
Yeah, so what you'll do is here you'll say, okay, so my mean is 3.7, my standard deviation is 0.9. So you'll come to Desmos and you'll just clear this one out and you'll do 3.5 minus 3.7 divided by the standard deviation was 0.9. Divided by the square root of 64. You get negative 1.777. So then you come here to your probability, and it said greater.
It said will be less than, so less than.
So that means we want the left side of the simulator. So we unselect this one, and then we put in negative 1.778. Hit enter. Then our area is 0.0377.
Okay.
So it's 0.038 once you round to the 3 decimal places. So yeah, you'll just treat that as like a new sample size, and then you'll just use that new GPA that they're trying to find.
Okay, so then going to question 9 and 10, and it's probably going to be along the same ways.
Okay.
So I got question 8 correct, which was the probability of 1 tank. So then the sample of 20 tanks.
Yeah.
Now that also though changed the, let's see, 8550, 8544. So on that one, you would take what, the 8550 and then subtract the 855 or 8 whatever 44 or whatever that is.
Yeah. So you do 8550 minus 8544 divided by 12 divided by
12 to the root of 20, correct? And then you put it back into the applet, and that gives you 2.236.
No, this one just wants to know the z-score. So the z-score is what we find from doing that equation. So
oh, okay.
Yeah, so the applet gives us the probability, and the equation gives us the z-score.
So on the next one, then, where it's 50 tanks, so you take and now this one asks for what will be the probability that the mean capacity for these 50 tanks will be greater than 8540.
Uh-huh.
So you take the 8544, subtract the 8540.
So you do it like this. You go 8540 minus 8544 divided by what's this?
12.
12 divided by and the sample size.
Square root of 50.
Square root of 50. So you get negative 0.2357. And then for the probability, I know I have to go to my applet, and it wants greater than, right?
No, once yes, you are correct.
And it was 2.357. So my probability is 0.9908. 0.991 because you round up from the 8.
Okay.
But anytime anytime it wants to know the probability, you're like, okay, I know I need to find a z-score, and then I need to put it into my applet.
Okay.
Anytime it says the z-score, no, you just have to do the equation, and then you're done.
Okay, let me pull that up right now so that I can just have that. You said it was Desmo, DESMO.
Yeah, DESMOS.
Okay. And at least I have that on my. It's in the back of my mind. I keep meaning to do it, but apparently I'm not. And is it the graphing calculator?
Yeah.
Okay. Are they going to let us? Can we use that for the test or no?
I think so. It's just a calculator.
Oh, there it is right there. Okay, right on.
Yeah.
Okay, so that, yeah. Okay, so now that makes more sense because I just could not. Yeah, I could not follow that and figure that out. So then, and I think, what did I get on I think I missed one on the other one, but I can't remember on number 6. I mean, on the 6th quiz.
Lesson 6.
Yeah. Dog, I can't believe that your feet, you think they taste so good. My computer is running really slowly today. I think it's about ready to crash. So
No.
I'm just hoping that it hoping that it holds together. Let's see, lesson 6. Lesson 6 homework quiz. Okay, so the first time I missed 4. The second time I only missed 1, though. Let's look at that one.
Okay.
Thanks for taking the time to do this. I appreciate it.
Oh, yeah, no problem.
Okay, so how is the mean of distribution? So it's question 8, and they're talking about the cancer spots. So how is the mean of distribution of sample of means related to the population mean of the number of cancer spots?
Oh, it's just, they're equal.
Okay, I did not put that down. Why are they equal, though?
I have no idea.
Okay, well.
I just caught on to the pattern that they're always equal, and then I just ran with it. I don't know. I really don't know.
Good answer, then. All right.
Yeah, I was like, I'm not going to do statistics for the rest of my life, so I don't care. I just want to pass the class.
Seriously, after this class, hopefully there's no more. Hopefully there's no more of these classes.
Yeah. It's. I'm like, no, I'm good. I don't care.
For sure.
So I don't know.
All right.
I thought that they were equal, so I just remember that because the means are equal.
Okay.
It's not super helpful.
Let's see here. Do you have a little bit more? Are you in a rush, or do you have more time?
No, I got some more time.
Okay. I will honestly tell you, I haven't even started the lesson 8 quiz.
Okay.
So I don't even know. I mean, let's see here. Oh, look, I met with my group and completed this group quiz with them. Well, that's awesome. So we were supposed to meet as a group. I wasn't sure. I was like, I hope somebody comes up. I certainly need help. Okay, so which of the following variables are categorical?
Hold on, let me pull mine up. I took it earlier.
Huh?
I took it earlier.
So that would be like the age of years randomly selected in vehicle parking lot. That's categorical, right?
No. Categorical is more like they're more like names, not.
Oh, so the toothpaste?
Yeah.
They're more like names, not amounts?
Yeah.
Okay, so if it said the make and models of cars selected in a parking lot, that would be categorical?
That'd be categorical, yeah.
Okay. Okay, so the randomly selected toothpaste. Gotcha. Let's see. IQ test is 100, 20 randomly selected stats, and their scores were 112. What is the following statement are true? Oh, I even haven't. Okay, so let's see here. So the mean, and what is the mean again? Is the mean the average?
Yeah.
Of the, like the halfway point, right? The halfway average?
Yeah, it's like the average data.
So you take them all together and then you divide by the number of them, or you divide by?
Yeah, yep, you divide by however many pieces of data you have.
Okay. So well, wouldn't the 100 be, would the 100 be a parameter and the 112 is a statistic?
Yep, nailed it, yeah.
Okay. Because the parameter is what you start with, right? And the statistic is what you come up with when you...
Yeah.
Okay. All right, let's see here. Rotham has 4 distinct neighborhoods, property values, very similar. Very considerable from neighborhood to low property values, high property values. How do they say they're very similar? But, oh, okay, very low to high. Usually high, roughly proportional to property values. What type of sample should we select to collect to gauge the residents' responses to a proposed increase in property taxes? What are my... Now, a cluster sample, that would be just like one neighborhood, correct? But you want to get a sampling from all the neighborhoods, correct?
Yeah. I put a simple random sample and I was wrong. So I'm wondering if it is cluster.
Well, either cluster is what's the stratified sample? The stratified sample is...
Oh, this is stupid. It's stratified sample.
Okay, so the stratified sample, isn't that where you take... I was going to say it was stratified, but I can't remember the exact definition of it.
Yeah.
I would think the cluster sample would just be one neighborhood, but you want something from all the neighborhoods.
Yeah. So it's when the items to be sampled are organized in groups of similar items called strata. Then a random sample is drawn from each of these strata. Works well when items are similar within each stratum and tend to differ from one stratum to another. That's dumb. That's a trick question.
Right. Okay. Question 5. When designed experiments are conducted in public school systems, researchers typically receive district randomly select teachers. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? So they choose a particular district and randomly select the teachers in those classes. So that's It's either a systematic random sample or it's a stratified random sample.
It's a cluster sample.
Oh, did I not go down? Oh, sorry, I didn't go down far enough.
Very good.
Okay, close. I thought, oh, there's only 4 choices. And it's a cluster sample, being that they used the same, like it's every 4th grade teacher in every school in that district. The students of every 4th grade teacher.
Yeah.
Or whatever, however they explain that.
Yeah.
Okay. Okay, school fundraiser. Every person who attended was entered into a drawing. At the end of the evening, 6 names were selected. That is very simple random.
Yeah. Yep.
Okay. Simple random sampling. Special interest, survey, wolves, Yellowstone. Adequately. Researchers registered, took a list of registered Democrats and selected a simple sample of 100 people, registered Republicans, and selected. Okay, now that one would be. Is that stratified random or is that voluntary?
Yeah, it's stratified random.
Okay.
It's the same thing like earlier. They took 2 different groups and.
Is that same as the house thing, right?
Yeah.
Okay. Just a different way to say it. So Crossroads, open the Crossroads purchases. Okay, it doesn't want to open for me. Of course it doesn't want to open for me. Nothing else is going like I want it to. Why would this open for me? Just because I keep clicking on it. Okay, so Crossroads purchases. Mine won't open.
Okay. You want me to share my screen again?
Yeah, if you would. I don't know why it won't open.
So this is just basically like what we did in like I think it's like the 2nd or 3rd week of class. So we take all that data from.
And then you find the mean, so the average, correct?
Yeah, and then we just pasted it into that like weird thing that they gave us. And so it wants us to find the mean. So just like here, it's 4.771.
Hold on, let me blow this up so I can see it better. How do I, let's see here. It's what?
Yeah, 4.771.
4.771?
Yeah.
Okay. Is this all just a review?
Yeah.
Nothing new?
No, it's
Oh my
just
goodness. Well, thank goodness for small favors, because my econ, we're also having a test this week. So it's a whole new chapter this week, plus the review.
Oh, nice. Got all of that.
So the standard deviation.
So you just would look on here, and it's just 1.11 or 1.112.
Okay, I'll have to see if I can't get. I don't know why it's not opening. Okay, start by creating a histogram of the amount spent in Crossroad purchases. Then mark the following statement, true or false. The histogram, that's the one that has the columns that come up, right?
Yeah, that's just this guy right here. This whole graph thing.
Okay, let me. How did? Oh. Okay, yeah, it is so not working for me. I apologize. I seriously apologize that it's not.
Okay.
I'll have to figure that out. Okay. Do they give you a form, or do you just create it? Do you just take the information and create the histogram on your own?
It just makes it. So this is like that spreadsheet that he had us using at the beginning of the semester. Saved it on my computer, and it just makes a histogram for you.
Okay. All right. So body temperatures, diving elephant seals, thermostat, location, body temperature decreases as they dive, estimate the body temperature, time they initiate dive is representative temperature. Okay, hold on, let me get here. Hepatic sinus of 4, so the liver sinus of 4 seals. Seal's body temperature start of the dive was that. What is our question? Complete the following. Okay, so the value of A of the number goes in the position. See, now I can't, it's this. I have a hard time with these Greek whatever thingies.
Oh, yeah.
Okay, what's the, so I get where the X is, but then the deviation from the mean, do we have, where's that information as far as?
In the story problem.
Did I miss it? I'm looking back at it and I'm not seeing it. Okay, hold on. So
you had to find that one. So what I did is I just took that spreadsheet and I just put in those 4 pieces of data. I just came over here and I cleared out all this stuff. It's 37.91.
So you have to calculate the quadrille whatever, right?
Yeah, they do have us do some of that later.
Okay.
Yeah, so I just did this because it said we could use this on the test. So I was like, okay. So then the mean is 38.075. So all we're doing for this part right here, for number 11, deviation from the mean, we're just taking 37.9 and subtracting that mean that we just found.
Oh, okay. And what was the mean?
The mean is 38.075.
So then 37.91. Is that the right one? My luck, I'll have the wrong. Would be 0.165.
It should be negative 0.165. So you do this value over here that you have, and then you subtract the mean from this value.
Oh, I did it backwards. Hold on. Okay. So it's a negative 1.165.
Yep.
How many questions are on this?
31.
Oh my gosh. Okay, we're not going to go through all 31 questions because I have to drive up like 45 minutes away here in a little bit. But okay, what's the value of the number that goes in the position marked with a B in the table above? So it would be the 37.25 minus the mean, and then you
square it.
Not what's the opposite of square root? It's the,
you just square it.
Square it. Okay.
Yeah, just whatever number's in this table, you just square it.
Okay. So that would be, what's the mean again?
This one is 38.07.
Actually, let's go down to, okay, so I can go and do, because I really don't want to, make you have to. go through every question with me because some of this I can. Okay, so the quantity is equal to the sum of the numbers in the squared deviations. What column? What quantity is equal to the sum of the numbers in the squared deviation column? So if you take all of those numbers in the squared deviation, shouldn't it be the, is it going to be the mean? No.
No.
Hold on. Because there'll be, no, it won't be the mean. And it's not going to be standard deviation. Is it none of it correct?
Yeah, yep, it's none of them.
Okay. The standard deviation of these temperatures remind me what the standard deviation is. The standard deviation is,
it's like how far they vary from the mean. So it's just,
okay.
I just got that spreadsheet. It just had a column that calculated it.
Okay, then let's just skip on. Under certain circumstances, the standard deviation can be negative. What had to stay positive? Something always had to stay positive.
The standard deviation does.
Okay. So that would be false. For it to work, it always has to be positive, correct?
Yeah.
Okay, researchers, thermostats, body temperature, spinal cord, brain, to the other seals. Okay, finally place 4 other seals. The results are this. Okay, so now which location resulted in the most consistent temperature? That would be the extradural.
Probably. I got it wrong because I put arterial, but I think that because the sample size was bigger, but I think the one that they wanted is extradural.
I mean, I'm only going to say that because the standard deviation is smaller.
Yeah, that's what I would. That's what I originally picked, and I was like, well, wait a second, is this a trick question? So I went back.
There's a fair amount of that, what seems to be trick questions, why they can't just be. Yeah. And the number of hours spent studying exam are recorded. Oh, plot box. Love the plot box. Okay. The third quart is 8, correct?
Third, yeah.
Okay. Percentage lies between 4 and 8. Example is, okay, what lies between 4 and 8? Two, 4, 1, 2, 3, 5. Five, what is that? 2. Is that 2/5?
I have no idea on this one. I was trying to look just now for better. I got it wrong. I have no idea.
What did you put down?
I put 75%.
I think if you look at, and I might be wrong, but I think if you look at it, so the data runs from 2 to 12. And so there's 5 sections of it, 2 to 4, 4 to 6, 6 to 8, 8 to 10. Wait a minute, 1, 2, 3, 4, 5. So there's 5. The way I'm looking at it is if you break it up into 5 equal segments, most of the data lies between 4 and 8. But in that would be like, if you look at it as 5 segments, most of the data lies between 4 and 8. So that would be like 2/5 of it. But I don't know that I'm right with that because that might be that might be really wrong. But then let's see, let's see if we do the math on that. So 2 divided by 5 equals, that would be like 40% of the data would sit there. I'm going to put 40 down, and Is this one we can take multiple times?
Yeah, we got to take it twice.
Okay, I'll have to finish it later when I get back from work, but to see. Okay, normally distribution, standard deviation, parts per million, risk, Rexburg, nitrate, water. Okay, so estimate the mean of the measured nitrate concentration in Rexburg's drinking water. And the mean is, oh gosh, so the mean would be, do you take the 1.59 and the 2.52?
That's what I did. I was adding them together and divided it.
And then you just divide it by 2?
Yeah, that's what I did. Well, I think I actually plugged them into that spreadsheet again.
Okay. Okay, so and then you would
yeah, I get it. So I put them in the spreadsheet earlier.
okay. So then what's the question again? The question is, did you get it right?
That one I did, yeah.
So estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. Now, when I did that, I got the mean as 2.055.
Yeah.
And then, oh wait, the mean, so 2.055, right?
Yeah.
Okay. And then the next question asks for the standard deviation. And the standard deviation would be
I got that one wrong.
Standard deviation has something to do with the U. Oh, okay. The mean is the mean the U, the schwa, the U schwa U thingy, and the standard deviation is going to be the whatever. So we just have to manipulate that formula. So if you put 2 point, so if we do 2.055 plus,
you know what we do?
I think if you just manipulate that formula and get that weird O thingy with the hanger thing by itself, that'll give you, that's the standard deviation. So you just have to manipulate that formula.
I think we do this. So we take, I think we have to go back and do those tables. So we do the deviation from the mean, then we do squared deviation from the mean, the sum of that, and then we have the variance, and we take the variance and we take the square root of the variance, and then that's our standard deviation. Does that make sense? Kind of.
Yeah, it does. I'm wondering though why they gave us those formula, like those equations though. The U minus the standard deviation of 2, or plus the standard deviation of 2, and then they give us an answer. I'm wondering if we can use those, is what I'm wondering. Because if you stick 2.055, if that's the mean, then you would put that in there for the U thingy or whatever. So it'd be 2.055 plus 2, whatever that schwa O thingy is, equals 2.52. But if you rewrite that formula, it'll be that schwa thing is equal to 2.52 minus 2.055 divided by 2. Does that make sense?
Oh yeah, yeah, we're saying the same thing. Yeah.
Okay.
And that's, yeah, so you do.
So let's see, 2.52 minus 2, oh gosh, I keep going 2.25. Okay, so 2.52 minus 2. What was our answer again for that? 2.055?
Yeah.
Is equal to 0.465, and then you divide that by 2. You're gonna get 0.2325.
So one thing we have to do though is first we have to sum up the squared deviation from the mean.
Oh.
So you take you take 1.59 minus 2.52, and then you do, or no, I'm sorry, minus 2.055. And then you take 2.52 minus 2.055. So we take both of those numbers and we square them. So you do 0.465 squared. And then you have, so basically it's okay, so we have, so we do 0.43245. 43245 divided by, so we take our sample size, which is just 2. 2 minus 1.
Okay.
And that gives us literally 0.34245. And so then we'll take the square root of that. Square root of 0.43245. So it should be 0.6. What the frick?
What?
It's the same thing I got earlier.
Okay, so and you got that wrong, correct?
Yeah, round your answer to 3 decimal places.
So what I'm thinking is that if we look at that equation that they give right there, so they're going to give you the standard deviation of 2 on either side, correct? That's why you have the -2 and the +2. The standard deviation is that little O thing. That's what the standard deviation is. We have all of the other information that we can plug into that equation to get the standard deviation. So just rewrite that formula, that equation. So like for the one where it's U minus 2O equals 1.59, because we already have the mean, we calculated the mean as, what was that, 2.055?
Okay.
So if you take, so taking that 1.59, so the easiest way to do
So what
it,
you're saying,
so what I'm saying is take 2.055, subtract the 1.59 from that, and then divide it by 2.
2
And what do you get?
I get 0.2325.
Okay, so now I already did the equation with the addition and the 2.52, and I got 0.2325. So I believe that that is the standard deviation, is that 0.2325.
Say that again?
Okay, so if you do, because what we're solving for, so we've calculated the mean in another question. And they want, this question that we're looking at is, they want what the standard deviation is in 3 decimal places. So they give you the equation. They give you these 2 different equations. So which is the two.
Oh yeah, you're right. Yeah, it works. You're right. That's, yeah.
So then your actual standard deviation rounded to 3 decimal points is 0.233.
Yeah, 0.233. Yeah. Interesting.
I'm all about algebra. I'm really good at that. So
Yeah.
okay, so now then between the two measured concentrations, now we put in is where is 60%, where is 68% of the data. So where's now 68%, is that 3 whatever, 68%, 91%, 99%?
Yeah.
So then that would lie between, so we have the two deviations. So then just go back to those equations. And instead of having the 2 there, you're just going to go 2.055 minus 0.233.
Yeah. Yeah. So it's the last one. It's 1.823 and 2.288.
Is it?
Yeah.
Okay. 2.88, 2.288.
Yeah.
Okay. So the following remaining questions: admissions, master business, okay, distribute mean, standard deviation, GMAT, BYU, 600. Okay, so the question is, what is the probability that a randomly selected student will score above 542.3? So then we take the 542.3 and we subtract the standard deviation, and that gives us and we divide it by, right? Am I on the right track, or am I?
Yeah, so this one, it took me a minute to get it. So let's see, what did I do? It was
because we find the z-score, we plug it in there, it'll give us the area, correct?
Yeah, so if you do, so if you start doing the z-score, you get 0 divided by 120.54.
You get 0 divided by 120.54?
Yeah, so the number they gave us is what is the probability that a randomly selected student will score above 542.3? Well, that's also our mean, so we have to subtract our mean from the value given. So 542.3 minus 542.3 is 0.
Is 0. You can't divide that by.
Yeah, so then what I did is I just went into the applet and I put that in, and I got the right answer, surprisingly. I was like, oh, okay.
So what does it say when you put it in the applet?
I put in 0 and you just get 0.5, so 50%.
You get what?
0.5.
0.5.
Yeah.
Okay. I'm going to have to do that. That's crazy. Okay, scope at lower 600. So it's going to be, is it 600 minus the 542 point whatever, or is it 542 minus the 600? I always get backwards.
So it's always the sample size minus, or it's always the value that they give us minus the mean.
Okay, so 600 minus the 542 point whatever.
Yeah.
So 542 point.
600 minus 542.3, and then you divide
0.3.
Standard deviation.
Standard deviation is 120.54.
You take that number and you put it in the applet.
And you get?
That. You get 0.684.
Okay. All right. What time is it? Oh, I gotta leave here in a minute.
So pretty much all of those
are just working with the applet.
Yeah. So 24 and 23 are exactly the same way, and then 25 for the 10th percentile. What you do is you just come to the applet and you clear everything out, and you say, and it wants to know, find the GMAT score that corresponds to the 10th percentile. So you go to the applet and you select the left blue one and you put 0.1 in up top.
In the area?
that, yeah, in the area. And then you take that z-score on the left.
Okay.
And you multiply, you multiply that z-score by, hold on, let me find the equation. So you multiply that z-score by the standard deviation, and then you add the mean.
Oh, okay. So you just work it backwards.
Yeah, yeah.
Okay, and that would be the same for 26.
Yep.
Let's see here. And then the first quartile of the GMAT scores, I can look that up, how to solve for that.
Yeah, I did not get that one right, but weirdly enough, I got the next one right, and I did it the same way. So
I just have to remember. I don't remember. Well, I'll just have to go back because I put it into Excel when I did it. So
that's all I did. I just used the
right. Okay, so 28 is the third quartile. Okay, random sample, 15 students. What is the mean distribution of sample means for such samples?
So it's just the same mean we've been using. So 542.3.
What have we been using?
We've been using 542.3.
That's what the answer is for that. It's so confusing. I don't understand. Like, they make it seem like I have to do all this math, and then they're like, no, it's just this because we said so. We just made it up.
Yeah.
Okay. So sample deviation of a standard of the distribution of sample for all samples. No, but that changes though, correct?
Yeah. So I just did the standard deviation divided by the square root of 15.
Okay. I'll do that later. Okay, probability score 15, and that is just going back to what we were doing with chapter 7. Okay. So right on.
Cool.
I'll go back and do the rest of these later. So thank you.
Yeah, absolutely. No problem.
Thanks for your help on the other two as well. That's
oh yeah, no problem. Let me know if you have questions on any of the other ones.
All right, I'll definitely for sure. Let me know how you did when you resubmit your. Did you resubmit it already?
No, I haven't. I need to go back and refill it out.
Okay. Yeah, I'm interested to see. Hopefully, between the two of us, we got those correct.
Yeah, no kidding.
Mm-hmm. All right, I'll let you go. And do we have whatever tomorrow too?
Yeah, because we have lesson 9 tomorrow.
Oh my gosh, I'm okay. Just 3 more days or 1 more week of 6 days a week. That's all I'm going to tell myself. All right, we'll see you tomorrow then.
Okay, sounds good.
Okay, bye.